So let's say you're given this diagram and they tell you that this object's under uniform circular motion. Could you tell me what the centripetal acceleration is? If not, continue watching this video and we'll look at it together. First, what is uniform circular motion? Uniform circular motion occurs when an object moves with constant speed. We got to be careful with this definition. Remember that constant speed just means the speed's constant, not the velocity. So when the object's moving, the direction of the motion can change, the speed does not change. So an example here we can look at is a car turning a corner at a constant speed. The velocity vector is constantly changing direction, traveling in a circular path, but this is a snippet at one certain point. And we can note that the acceleration is pointing inwards, and it always has to be pointing inwards because if it wasn't, it would no longer be circular motion. The object would move in another direction. From this diagram, the important thing to take away is A is always going to be perpendicular to the velocity vector. Otherwise, the velocity would change. Now we can look at this situation again. So I just want to identify that delta S is the distance between P1 and P2, and we have this change in angle phi, and that's just the change in the angle relative to the origin from P1 to P2. And then we can also define delta V equal to V2 minus V1. That's just a change in velocity from P1 to P2. We can draw the V1 and V2 vector from the same origin and create this triangle here, and then we can draw the delta V pointing from V1 to V2. The important thing to know is this angle here between V1 and V2 is also phi, so we can relate it to the current diagram that we have, and we can note that these two triangles are similar triangles. We can create a ratio with that. We can create this ratio here where delta V over V1 is equal to delta S over R, and then we can isolate for the change in velocity and get this equation here. This is important because now we can apply this to the general average acceleration equation, which is right here, and if we plug it in, we get this value here for the average acceleration. Now what we can do is get the instantaneous acceleration by taking the limit, just like we did previously. And if we take the limit here, we can take the V1 over R out because it doesn't rely on delta T, and then we can take the limit of this term here. And we can note as delta T gets smaller, P2 is going to become closer and closer to P1. So that just means the velocity 2 is just basically becoming velocity 1 because it's getting so close to that point. So we just plug in V1 and we get this expression here, and we can generalize and get the final answer here, which is acceleration is equal to V squared over R, where R is the magnitude of acceleration of the object in uniform circular motion, V is the speed of the object, R is the radius of the object's circular path. And I just want to note that this is also equal to centripetal acceleration because centripetal acceleration just means acceleration in the motion of a circle.